This is lesson 2.5. Oh, no, not those. Oh, dang it. Get really excited. So we talked about measures of center, like the mean and median. Talked about measures of variation, standard deviation, the most common, and then we're going to end up with measures of position. So this kind of gives us just like a little bit of like the spread of data, like which we have talked about a little bit too with like the bell curve. But we're going to talk about something called like quartiles, which are pretty common when doing some statistic work. So basically we're just going to kind of like divide out our data and kind of look at like some characteristics within each, fractile, but we call them quartiles because we're going to split them up into 4 equal parts in order to calculate some statistics like the interquartile range and outliers and stuff like that, outliers. So a quartile is when we divide our set into 4 obviously equal parts, and our second quartile, so if you look at this picture here, our second quartile is another word of like the median, is another thing they call the median, because you split your data right in half. And so we call the second quartile that 50% of our data is either going to fall below or above. So it's obviously in the exact same spot as the median. Okay. Some notation you'll often see like the Q sub 2. That means second quartile. So this is just notating that 50%, so exactly half of your data, is going to lie below or above the second quartile or the median. I think Alex just keeps it consistent and calls it a median. I don't think they use that second quartile, but they do use that Q sub 2 notation, which that stands for second quartile. 50% of the data falls on or below. Okay. So the first quartile, which is sometimes called the lower quartile also, you can see that in the little picture, is we basically take the first half, and if we were to calculate the median of the first half, or again, section it off into 4 equal parts, so if I took half of a half, that's really a 4, that's what my lower quartile is. So it's basically the median of the lower half of my data. So that means that 25% of my data lies on or below the first quartile. Oh shoot, I forgot to put Q1. Q1 right there is a notation for that. Sorry, add that in wherever you want. Okay, so the first quartile or the lower quartile, after we find the median, we just take our bottom half, calculate the middle of that. So it says that if your lower quartile, like in this data set, is 17, 25% of your data lies on 17 or below. Okay, hence the quartiles. So here's the median, second quartile. So then if I were to split it up again, so I have the 4 equal parts, the quartiles, I could find the median of like the upper half of the data. We call that the third quartile, or sometimes it's called the upper quartile. Q3. So it's basically the median of the upper half of the data. So if we look at the upper quartile, we know that 75% of our data lies like below or on that upper quartile. So there's one way to kind of measure like the spread of data by more than just looking at like what the middle is, but what's like the middle of the bottom half and the lower half. And there's ways to kind of like display this and just get like a better spread of your data set, I guess is really what they're used for. Okay, So there's the vocab. Let's try an example. Here are some distances of the nearest airport for 14 families. These are in miles. Notice that the numbers are ordered already from least to greatest for you. You have the median, lower quartile, and upper quartile. Okay, so median, that's another word for my second quartile. Lower, first quartile, and upper, third quartile. How are we going to notate it? Okay, so I always start by finding the median. We know how to do that, especially when it's already listed for us in least to greatest order. So if we have 14 families, I'd count 7 in, or again, you can kind of cross off as you go. I'm not going to do that, but 1, 2, 3, 4, 5, 6, 7. Right here would be my median, and we know if it lies between 2 values, we have to find the average or halfway. So that would be 28 and a half. Okay, so there's my median on my second quartile. So then, now that my data is split in halves, I'm going to split it up into quartiles. So I'm looking here, and if I want to find the lower quartile, I'm just finding the median of like this lower half. All right, so now I see I have 7 datas in my lower half, 7 data value points, I should say. So the median here, or my lower quartile, would just be 17. You can mark this if you want. So there's Q1, Q2, it's right in the middle. So then Q3, or the upper quartile, those mean the same thing. Is the median of my upper half. All right, so again, I have 7 data values. So right here, that'd be 35. And those quartiles would split my data into 4 equal parts. The other thing I would say is like another way I can interpret this is that like 25% of our data would be at 17 miles or less. 50% of the families would be at 28.5 miles or less. And 75% of our families are within like 35 miles or less of this airport. All right, here's another statistic often measured with quartiles, something called the interquartile range. And we know how to find the range with a normal set of data. It's like our highest minus our lowest, just to give us a little bit idea of like the spread or how spread out our min from our max is. So the interquartile range is you just find essentially the range of the upper quartile and the lower quartile, okay? So you'll often, here's like the textbook definition, a measure of variation that gives the range of the middle portion of the data. So it kind of like tells you like how far spread out your lower half median is from your upper half median, okay? It's often abbreviated as IQR. So if you see that, that's interquartile range. And it's just the difference between the third and first quartile. So you're just finding essentially the range of the upper quartile and the lower quartile. This one really gives you a measure of spread. So if you know like your interquartile range is really, really large, and that's telling you your data is very spread out. If the interquartile range is like a smaller value, like here the interquartile range is 13 after I calculate my upper and lower quartiles. If it was way larger, I know that my data is way more spread out. Okay, if that makes sense. All right, so we're going to do one where we calculate the interquartile range. Have you guys ever seen box and whisker plots? That uses quartiles, and we'll get into that. That's like one way of displaying quartiles. Let's see if I can show you a quick example. Not that. Like that. This is really where it's used graphically. Okay. We will talk about the 5-number summary in a little bit later because that's how you construct box and whisker plots. But in ALEKS, they tell you what it is. So here are scores of 11 students on a geography test, ranging from 59 to 89. Notice that the scores are ordered from least to greatest. Thanks, ALEKS. Give the 5-number summary and the interquartile range. So they want us to find the min, max, median, lower quartile, upper quartile, and then that'll allow us to calculate interquartile range. All right, you guys can just shout it out. What's the minimum? 59. Thanks, Allison. 59 is the lowest score. Maximum? 89. Good. All right. Median, what do we think? 68. Yep, this right here would be the median. All right, lower quartile? 64. Yep, the median of the lower half. Good. Oops. Upper quartile? 83. Good. So to find the inner, exactly what it sounds like, the inner quartile range, we just take the upper quartile. We're taking the range basically of these quartiles to give us a little bit of an idea of the spread of like the middle of our data. So in this case, our upper quartile was 83. Minus 64. So that would be 19. Okay. A little bit easier math than finding the standard deviation. We can use interquartile range to identify outliers in our data set. And we're going to do one in a second here, but let's first refresh what an outlier is. So it's basically like a data entry that's either like way above the highest or like way below than like your min or max value. So if we're looking here and how the data is all kind of clustered together, I don't know what this graph is from, some like midpoint here, and we have this one extremely high value that's an outlier. All right. So if I'm given this, here's 11 scores that were put in the grade book in Professor Richardson's class. Which one of these are outliers? So I'm looking at these range and I'm like, whoa, 15 is way below. And then it ranges, 73, 78, 89, 93. And then, whoa, someone scored 191. Those would be outliers. Okay, so here's how we can use interquartile range to identify outliers. Another pretty common statistics. And then we'll look at a couple boxes and answer your thoughts. Okay, so this is kind of just a step-by-step process. But Alex kind of walks you through it too. So it says the following numbers of people attend the last 10 screenings of a movie. Complete the parts below to identify any outliers. So A says let Q1 be the lower quartile. We know that stands for first quartile. Q3, third quartile is the upper quartile. Find these in your data set. Okay, why don't you guys go ahead and do that. Find Q1 and Q3. Okay, I got 197 for Q1 and 210 for Q3. Median would be 206, just the same as Q2. All right, next step says go ahead and calculate the interquartile range. So my IQR is my Q3 minus my Q1. Okay, IQR is 13 in this case. So then we multiply it by this factor of 1.5 because that just kind of gives us a little bit of like an idea of how far away like the spread of data is from our IQR to kind of give us some what we call like boundaries. Okay, so once we actually do the math, I'll kind of show you the numbers here. So it says calculate the lower boundary by taking your lower quartile minus 1.5 times the IQR. Okay, my lower quartile was 197. So then I'm going to take 1.5 times 13, and I'm going to subtract that from my 197, and that's going to give me what we call our lower boundary. So it's just basically kind of like a factor that it's always going to be 1.5 that we multiply this by, just to give us an idea of like, if your interquartile range is 13, your data should fall within these boundaries. It kind of comes off like from the fact that like, oh, well, 25% of my data lies, on or below my first quartile, 75% between my third quartile. So that's kind of where that concept comes from. You don't need to know where it comes from. You just have to use it. So I got this number. So based on the range, my interquartile range of my first and third quartiles, none of my data should really be lower than this, is what that's saying. Okay, let's do an upper boundary the same way. So this time I'm going to take my third quartile, I'm going to add 1.5 times my IQR. What was my 210? Times 13. Okay, for that one I got 229.5.
Wait.
Okay.
What did you get?
Sorry. I got
Don't mess it up.
229.5.
Don't you do
Somebody else gonna do.
197 minus. Oh, wait. Is that after you multiply and stuff?
You could type it in just like this.
Oh, do you do 1.5 times 13?
Yeah.
Oh, that's what
Yeah. Yep. Oh yeah. Order of operations. Hem does.
Yeah.
Okay, so basically how this helps us is it factors in our upper and lower quartiles where like most of our data is spread in relation to like the median. Okay, so it's like this interquartile range says, hey, we only have a difference of 13. That's funny, that was what ours was in this example too. We have a difference of 13 between the median of your lower half and the median of your upper half. So anything that's 1.5 times outside that range would be considered an outlier. It's basically like the math we're doing here. And again, that 1.5 constant, that will be given to you. So it says any values less than the lower boundary or greater than are considered outliers. Identify if we have any from our data set. So looking here, I have 2, which you probably could have figured out by looking at the list since you know what an outlier is. But that's less than my lower boundary, and that's greater than my upper boundary, so those would be considered outliers. 113 and 295. That's statistically how we would determine if they're outliers, not just by like looking, be like, oh, this looks like it's way far removed. We could use the interquartile range to actually like calculate that. Okay, the last thing I want to do today is look at some box and whisker plots, since these are graphically how we represent quartiles. They're also sometimes called box plots. And it basically displays all of these statistics that we've been calculating. It's a way of displaying it. So the reason why they're called box and whiskers plots is because in the middle you have this big boxy looking thing, and then you have these two kind of like end segments that are called the whiskers. So what this is really showing you, if we look at the box piece of this, the left side of the box is your lower quartile, your Q1. The middle of your box is your median or your Q2, second quartile. And the right value over here on your box is a Q3. So obviously the difference between those, that's your interquartile range. Okay. The whiskers parts, these segments, show that, okay, we do have some data obviously below where my lower quartile is. And then wherever it stops, like that's got to be the lowest point in my graph. They don't all look just perfectly symmetric. Like if we look, like this one's pretty skewed. Okay, like you can see your median is in here. So it just kind of allows you to, again, see like the spread of your data. We'll take a look at that in a second. And then this whisker over here as well shows you all the values that are above your upper quartile and then also your max. Okay, so again, the only thing I maybe write here is that our lower quartile, that means that 25% of my data lies here or below. So 25% of my data is this number or less. 50% of my data, right in the middle where my median is, lies on or below the median. And then the upper quartile, 75% of my data lies here or below. So basically in a box and whisker plot, the whiskers kind of shows us like the spread of like our min or our max, where we can calculate the range from the whiskers. And then the box kind of shows us where these quartiles are in relation to like the mins and the maxes. Okay, so we'll just interpret some today, and then when we come back on Monday, we'll actually like make a box and whisker plot. We could maybe, I guess, finish this whole thing, but I'd rather spread it. Get it? Because it's measuring spread. Okay. Thanks. That's funny. Don't you guys want to save some of this for Monday?
Yes.
We can't work too fast, and we're gonna have to start something else before spring break. We want to do that. You're gonna figure it out.
Yeah.
Okay, a farmer weighed a sample of pumpkins from her crop. She recorded the weight in kilograms of each pumpkin. The box and whisker plot, sometimes called a box plot, summarize these weights. Okay, so here's my whiskers, here's my box. What do we think is the median weight? 31 is correct. Yep, so in the box, this middle part, that's my median. You can label it Q2 if you want. If I look down here, 31 kilograms. That would be how we interpret that. Good. What is the, let's say lightest, so the highest. What is the lightest weight?
16.
It is 16. So I got to look on my whiskers. This is my min over here. Look down here. Uh-oh. 16 is correct. Let me lock this in quick. All right, last question. What is the first quartile? Or you could think of this as like the median of the lower half of the weights. Yep, that's this part of my box, 26. Okay, yep, that's how you would interpret that. Okay, let's do one more where we're kind of given two box and whisker plots compared side by side. We have two athletes that are training for a cycling race. Each athlete recorded the distance in miles of their previous 60 training rides. The box and whisker plot below summarizes the distances recorded for each athlete. All right, so we have athlete A here, athlete B. Which athlete had distances with a larger interquartile range? So interquartile range is my difference from the third quartile or the upper upper quartile, whatever you want to call it. The difference between that and my lower or my first quartile. So looking at those two spreads, which one will have a greater IQR? Athlete A. Yep, athlete A. Obviously, this difference between these two numbers is going to be bigger. Which athlete has a smaller range? So here we kind of have to look at the mins and maxes. So you can see athlete A ranges from 14 to 37, athlete B 22 to 34. So definitely B has a smaller range. Which athlete has a greater median? What do we think? Maybe this middle piece? B. Median is the middle. Athlete B has a median of 28. Athlete A's is 22. All right, last one. We'll call it a day. Which athlete went on the shortest training ride? A. A. Yep, look at their mins. A had the lowest with 14. That just sounds terrible. Can you imagine biking 40 miles?
Couldn't be me.
Okay, so there is an Alex assignment. You could probably start it right now if you want. Because there are quite a few questions, but honestly, a lot of them are pretty quick.